All right, in this video we're going to take a look at simplifying algebraic expressions, and we're going to look at two key things. We're going to talk about some terminology, and then we're also going to talk about actually how to do it. So I've got just some sample problems here that we can work through quick and kind of see how this all goes. So let's start at the top. We're asked to identify the terms, so let's underline that because that's an important word. Like terms, coefficients, and constants in each of these expressions. Now we're not going to do all of these because this can be kind of time consuming, but I want you to get the idea. A term, when we're dealing with algebraic expressions, is anything that is separated by either addition or subtraction. So, for example, in this first problem, we've got 6y minus 4 plus y. The terms in this case are the 6y. Now notice, this is a negative 4. Just because we have subtraction here doesn't make this positive. It makes it have a negative value, so a negative 4. And then the last term would be y. So if we're asked to identify them, in other words, just list them out, I could say that my terms are the 6y, the negative 4, and then the y. So again, terms are simply those sections of our expression that are separated by addition or subtraction. So if we looked at number 2, okay, as another example, we again have three terms, the 8u, the 2u, and notice this is a negative 3u. So we have three terms in that case. Or if we look down here at number 6, we've got 1, 2, 3, 4, 5 different terms. Again, 5 different distinct sections separated by either addition or subtraction signs. So again, those are terms. The next item that we need to identify are all of the like terms. Let me write that down. So we have like terms. Now, in this case, we're looking for terms that, as the name would suggest, are alike. So let's take a look here in our first example. I've got a 6y, and then over here we have a 1y, or sometimes we'll just refer to it as y. These are like terms. They have the exact same variable. So in this case, the only like terms I have are 6y and y. Notice this negative 4 is not a like term. It does not have a y in it. So it's not a like term. We'll simply ignore it. If we look at an example like number 2, notice all of these are like terms. They all have u, u, u. They're all the same. But let's look down here at number 6. We've got some different things going on here. Notice I've got this term that's just an f. Well, notice there isn't another term out here with just f as a variable. Notice these two terms have f's in them, but they also have a g. So they would not be like with this first term. Notice this term, the 2g, has just one variable as well, but it's only a g. Notice nowhere else do we see a term with just a g. However, this negative 3 fg and this negative 1 fg, those would be considered like terms in this case. They both have f and g as part of the term. So if I were to make a list here, the only ones that would be listed would be this negative 3fg and this negative 1fg. They're the only like terms going on here. Or if we looked at something like 5, notice we've got a 8a and a negative 3a. We could list those two together. Or this positive b and this positive 4b. Those could also be listed together as two sets of like terms. All right. Coefficients. Coefficients are numbers that occur with a variable. So for example, in this case, 6 is a coefficient. Let's see if I can spell it right. Of course, I should be able to. It's spelled out right there, shouldn't I? Okay. So coefficients are those values that are in front of a variable. So this 6 and this y are being multiplied together. So one of my coefficients is a 6. Notice I also have another coefficient here, even though it's not written. Right here with this 1y, we could put a 1 here. 1 times y is still y. So we do have a second coefficient, even though it's not written in. If we look at number 2, notice we have 8, 2, and this negative 3, all of which are coefficients. If I look at this next one, negative 12, 5, and a negative 1, those would be the coefficients in that case. So again, coefficients, the number that comes in front of a variable. Last thing we need to look for are constants. Now, constants are different than anything we've talked about so far. And the reason we call these constants is because their value doesn't change. Notice this y, I could make anything I want. It doesn't really matter what y is because there's no equal sign. So I could make this y equal to 5, 6, a million, negative 3, it doesn't matter. But a number like negative 4 is always going to remain the same. Negative 4 is negative 4 is negative 4. So this is my only constant in this case. Its value is negative 4 no matter what. Now I can hear what some of you are saying. What about this 6? Isn't 6 always 6? Well, notice what's happening here. I've got 6 times y. So while 6 is always 6, the value of this term, well, depends on what y is. So even though 6 doesn't change, the y could. But if we look here with -4, there's nothing to alter it within the term. -4 is -4, so it's the only constant here. If we look at example 2, notice there is no constant. Okay, all of these have a variable attached, so all of them could change in value once we multiply. Notice in number 3 here, we've got an 8 for a constant. Down here, we've got a +1 for a constant. So those are what each of those terms mean. Again, term, those sections separated by either addition or subtraction. Like terms, those terms that are similar. So for example, our 6y and our 1y, those are like terms. Coefficients, those numbers that appear in front of variables. And notice I have not written down the variable. I don't have 6y listed here for my coefficients. I just have the 6. Notice I don't have 1y written here. I just have the 1. So notice if I came down here, if I wanted to list all my coefficients, I would write 8, 1, -3, and 4. I don't care what the variables are. I'm just looking for those numbers in front. And then finally we have our constants. Constants are those numbers that don't change. They're all on their own, like our -4 here, or our +8 here, or our -1 over here. Constants. Numbers that don't change, they're a term all on their own. All right? So hopefully you now have a better idea of the terminology, and if you ever see problems like this in class, you can work through them. All right? Well, let's jump down here a bit. Now we're going to talk about simplifying expressions. To simplify, what it means is to work through as much as you can. So do as much work as possible and then stop when you come to the end. It does not say solve. Okay, I'm not trying to figure out what Q is in this case or what H is in this case. I couldn't care less what these variables are worth. I'm just going to do as much work as possible to get it simplified. So what does it mean to be simplified? Well, in this case, I'm going to combine all my like terms. So this first term and this third term need to be combined. So a -8 plus a +5 is -3q. That q doesn't look much like a q, does it? There we are. And then this constants, we've got 6 and -3. I can combine those to get +3. Notice these aren't like terms. I've got one that has a variable, one term that does not. So I'm done. I've simplified as far as I can go. Let's try one more like this. Let's look over here. In this case, I've got 3 like terms. 1, 2, 3 of them. They all have h's. So this is 1h plus 5h, so that would be 6. And then 6h minus another 6h is 0h. So let's just write that down for the time being, 0h. And then our final term, which has nothing to work with, is just this -3, a constant. So let's write it down, subtract 3. Now a question for you. Do I really need to write down 0 times something? Okay, hopefully you said no. So no, we don't need to do that. So this 0h really doesn't need to be there. Our final simplified form will just be -3. I don't care that there's 0h's there. Nothing changes if there's 0h. Right. The other way we need to know that we've simplified an expression is if we have any sort of grouping symbols. In this case, we've got parentheses here in problem 10 or parentheses here in number 9, number 12, and others. No parentheses are allowed. Well, notice in the case of number 10, we'll use it. I can't subtract this 2 and this b. It doesn't work. They're not like terms. So what are we to do? If in order to simplify these parentheses have to go away, what are we going to do? Well, we're going to reach for our distribution. I'm going to take this -2, and by the way, I'm going to add a line, change the sign, just to remind myself that that is a -2. And we're going to distribute it to the b and to this -2 by multiplication. That way we can kind of bypass this whole, oh crap, these numbers don't work together, by going ahead and just distributing what's on the outside. So let's rewrite it. So we'll have b plus -2 times b is just a -2b. And notice, that's what this says, -2 times b. I really haven't done much work here. This last one, -2 times another -2, well, that's a +4. Well, notice we've gotten rid of the grouping symbols, but that doesn't mean we're simplified. I still have terms here that are alike, and we can combine them. So a +1b plus a -2b is a -1b. Now notice I didn't write the 1 coefficient. Typically in math, we're not going to write those 1 coefficients. We're just going to leave it as is. In this case, since it's -b, I'll write it that way. So these two terms have been combined. This constant can't be combined with anything, so we're just going to write it down. +4. So there we are. We've taken this not too terribly complicated ordeal, and we have now simplified it. This original and this new version are exactly the same. They have the same value. So when we simplify, we're really not changing anything. We're just making it easier to look at. Let's try a couple more. Oh, where's a fun one? Oh, let's go down here to 17. Let's try something that's really a challenge. So notice 17, we've got a lot going on here. We've got x's, we've got y's, we've got distribution that needs to be done, so let's get to it. First thing we want to do is get rid of these grouping symbols. Okay, again, we're still going to follow order of operations, now and forevermore, amen. So I'm going to take 12 times x, 12 times y, and let's see what we get. So we'll rewrite everything. So negative 14y, oops, forgot my 1, plus 12 times x, so that's just 12x, plus 12 times y, well that's just 12y, minus 12x. All right. So notice we've gotten rid of the grouping symbols, those parentheses, but we still have terms that are alike, so we need to combine. Well, notice I've got a positive 12x here and a negative 12x here. Well, if I add those together, they zero out. So positive 12 plus a negative 12 is nothing, so who cares about those? Now I've got a negative 14 plus a positive 12. Well, negative 14 plus 12 is negative 2, so we'll write down negative 2y, and we're done. All right. We'll do one more real quick. Oh, let's see here. Oh, let's try number 20. 20 has been designed to try and throw you off, even though it's really not all that difficult. Let's take a look. Notice we still have our grouping symbols here with this 8 and negative b, and we can't combine them. And notice the number that we're going to distribute, like some of these where the number was in the front, now it's in the back. No big deal. We're just going to distribute, same as always, except the number's in the back side. So negative 3 times 8, and negative 3 times a negative b, and we'll work from there. Negative 3 times 8, negative 24. Negative b plus, or excuse me, times a negative 3, well, negative times negative is positive, so plus 3b. And then we'll just write out everything else. So plus 6b plus 12 minus 10b. Now, I recommend that you write these steps out. A lot of you are going to get into the habit of these easier ones. Well, I'm just going to do it all in my head. Well, then you get to problems like this where you've got, let's see here, 1, 2, 3, 4 terms. Once you multiply, you end up with 1, 2, 3, 4, 5 terms, and you're going to try and keep all 5 of those terms in your head. And let's be honest, folks, some of you can't hardly write your name without asking anybody how to spell it. Why in the world are you going to try and keep track of 5 terms in your head? Write it down. It's going to make your life a lot easier. So let's go through and deal with everything with variables first. Notice how I've written all this. I've written all those terms with variables first, constants last. Variables first, constants last. And that's just the form that we typically use in math. It's not a hard and fast rule, but it makes our lives a lot easier when we're comparing answers. So I'm going to make sure all of these terms with variables are going to go first. Notice all of my terms with variables happen to be like terms. So 3 plus 6, okay, that's 9. 9 minus 10, well, that's a negative 1. So a negative 1b, and again, notice I didn't write the negative 1, I just wrote negative b. So I'm going to go through real quick, mark those out, don't want to use them again. Now I've got negative 24 and a positive 12. Well, if we add those together, we'll get negative 12. So we could write this one of a couple ways. We could write it as negative b minus 12, okay? Or, if that doesn't suit your fancy, we could do negative b plus negative 12. Both of these mean the exact same thing. They're just written a little differently. Personally, I prefer the first one. It's a lot cleaner looking. If you're having trouble, though, with making sure you know negative is negative, well, then go this route. That way you know, hey, that is a negative 12, and you're not tempted to treat it like a positive. All right? I hope this helps. So again, this is just simplifying algebraic expressions, dealing with our terminology, and then just actually working through it. Again, if you need help, come by, see me before classes get started, and I'll be happy to help you.